Hey guys, welcome to my video. Here we will be reviewing areas under function from section 4.1. Consider the function f of x equal to x over x plus 2. Approximate the area under f on the interval 1 to 4 using left sums with a number of 3 rectangles and right sums with the rectangle's width being 0.5, which I have labeled here. We will first draw out the graph of the function. We know that there will be a vertical asymptote of -2 because when we equal x plus 2, it will equal -2, which I will write right here. So x plus 2 equaling to 0, take away 2 from both sides, and we get x is equal to -2. So now we will draw the graph. So we have this. Okay, so we'll put -2 over here since that's the vertical asymptote. And then the interval is 1 and 4. Okay. So now that we have drawn this portion of the graph, we will look for the y values or the f of x values by plugging in the x values between the interval 1 to 4 into the f of x function and solving for y. So we got f of 1, and we're going to put the x value, which is 1 in this case, and put it into the f of x function, which we will get 1 over 1 plus 2, which is 1 over 3, which is 0.333. Then we're going to do that for f of 2, which we get 2 over 4, which is 0.5. Then we get f of 3, which is equal to 3 over 5. Which is 0.6. We're going to do that at f of 4. Which this will equal to 0.667. Okay. Now that we have found the f of x values, we will plug in these points on our graph and draw our function. To help solve the sums a little bit better, or make it more easier, we will also draw a table. Okay, so we can tell that this is increasing. So we're going to draw our function like this. Now, since it asks for the number of rectangles to be 3 for the left sums, we're going to draw 2 and 3. So we're going to do 3 rectangles. This is 1, 2, and 3. Okay, now to draw the table, we're going to have x over f of x. So for 1, we had 0.333, or 1/3. And then for 2, we had 0.5, or 1/2. Then for 3, 0.6, and then 4, 0.667. Okay, so from 1 to 2, this is rectangle 1. From 2 to 3, this is rectangle 2. From 2 to 4, that's rectangle 3. So we have rectangle 1, rectangle 2, a rectangle 3. We know that to find an area, we multiply the width and the height. In this case, we have to multiply x with f of x. So when looking for the left sums, we will need to multiply the f of x value that is on the left side of the rectangle, which in this case is 0.33, we have to multiply that by the width of the rectangle, which in this case is going to be 1. We will do this with the 3 rectangles. And then once we have this set up, we will add the areas together, which will give us the area of the curve using the left-hand sum. Okay, so from 1 to 2, the width is going to be 1. So we'll have 1, and we'll multiply that by the f of x. So in this case, 0.333 is on the left side. We will use the left side value since it is a left-hand sum. Then we're going to add that to the rectangle 2, which is 1, since that's the width. We're going to multiply it by 0.5 since it is on the left. Then we're going to do that with rectangle 3 also, which is 0.6, since again it is on the left. So this is rectangle 1, rectangle 2, and rectangle 3. Now that we multiply these together, we're going to get 0.33, 0.5, and 0.6. So when we add these together, we get 1.433. This is the area of the curve using the left-hand sums, which is this. This is the left values. Now for part B, we will do the same thing we did for part A, except since it is asking for the right-hand sums with the width equaling to 0.5, we will look for the y values or the f of x values of 1.5, 2.5, and 3.5 and add that to our table. Okay, so we have f of 1.5, so 1.5 plus 2, this will equal to 0.429. Now we're also going to do that with 2.5. This is equal to 0.556. Then finally we're going to do this to 3.5. So 3.5 over 3.5 plus 2. This will equal to 0.636. Okay, now that we have found our f of x values for 1.5, 2.5, and 3.5, we're going to add that to our table. And in this case, we're going to redo it again since it's going to be a little bit longer. So you got x and then f of x. So you got 1, 1.5, which is 0.429, 2, which is 0.5, 2.5, which is 0.556, 3, which is 0.6, 3.5, which is 0.636, and then 4, which is 0.667. Okay. Now that we have drawn our new table, we have from 1 to 1.5, we have a width of 0.5, 0.5, 0.5, 0.5, and so on. Okay. So from 1 to 1.5, that's rectangle 1. From 1.5 to 2 is rectangle 2. 2 to 2.5 is rectangle 3. 2.5 to 3 is rectangle 4. 3 to 3.5 is rectangle 5. And then rectangle 6. So now, since the width is half, what you're going to do to this graph, we're going to have 6 rectangles instead of just 3. Okay. So again, we know to find the area, we have to do width times height, which is in this case the same as x times f of x. So we're going to do the same thing we did with the left-hand sum. Okay. So since the width is 0.5, we will have 0.5 times that with the f of x values that is on the right, since this is a right-hand sum. So in this case, this will be 0.429 for rectangle 1. Rectangle 2 will have 0.5. Rectangle 3, we have 0.556. Okay, then for the fourth one, we have 0.5 times 0.6, since it is on the right. 0.5 times 0.636, and then finally 0.5 times 0.667. So again, we're going to multiply these values, and then once we find that, we're going to add them together. So for rectangle 1, we get 0.215. For rectangle 2, we get 0.25. For 3, 0.28. 0.3, 0.32, and 0.334. 1, 2, 3, 4, 5, 6. And adding this all together will give us 1.699. So this is the area of the curve using the right-hand sums with the width of 0.5. Okay. Now for the true or false question. If f of x is an increasing function on the interval 0 to 4, then using the left-hand sum on this interval would be an underestimate. Okay, so if we look back at our graph in our table, I'll draw our graph again down here. Okay, so over here is 0, over here is 4. So we got 1, 2, and 3. I'm going to draw 4 rectangles for this. Okay, so since it is asking that if we use the left-hand sum, the interval would be an underestimate. So like we did up here, we will take the value that is on the left. So for right here, since it's down here, it will stay down here. For rectangle 1. I'm going to do rectangle 2, rectangle 3, and rectangle 4. On the second rectangle, the left is shorter than the right one. And then for rectangle 3, the left is shorter than the right, and then so on. So it will be like this. Okay. Now looking back at the table here, we see that the f of x values on the left side are smaller than the one on the right. Like 0.333 is smaller than 0.5, 0.5 is smaller than 0.6, and 0.6 is smaller to 0.667. And because of that, we are taking the smaller value of the rectangles. And since we are taking the smaller values of the rectangles, when we add them together, we get a small value. And because we get a small value, that is the minimum. And because it is a minimum, it is an underestimate. So if f of x is an increasing function on 0 to 4, then using a left-hand sum on this interval would be an underestimate. So this will be true.